January 2005. NASA launched a unique probe into space with the mission to discover the origins of water on Earth. This probe, named Deep Impact, traveled over 270 million kilometers to reach a comet that held secrets humanity had been searching for centuries. Now it became the only known place in the universe capable of supporting human life. The universe is vast, yet Earth is the only place we know of where humans can live without external support. It seems almost like Earth was designed specifically for life. It has all the essential elements: water, food, and oxygen. But billions of years ago, Earth did not exist. Our solar system and Earth now occupy a spot on the edge of the Milky Way galaxy. Back then, instead of planets, there was a massive cloud filled with dust and gases. This cloud, known as the molecular cloud, was where the origins of our solar system began. The molecular cloud was made of particles containing sand, silicon, and various metals. It was formed from the remnants of dead stars that had exploded, scattering debris across the universe. Captured by the Hubble Space Telescope, this cloud was massive, 100 light-years across. To put that into perspective, it was 6 million times the distance between Earth and the Sun. This enormous cloud was the birthplace of new stars and planets, driven by one powerful force: gravity. Gravity, the force that draws objects towards one another, played a critical role in the formation of our solar system. As particles in the molecular cloud started to clump together due to gravitational attraction, they collided, generating energy that heated the cloud's core. Over millions of years, this process continued, causing the core to become larger, spin faster, and heat up even more until it transformed into a blazing fireball, our Sun. The remaining particles and gases around the newly formed Sun began orbiting it. These particles would eventually form planets, moons, and other celestial bodies. But how exactly did this happen? The theory of stars and planets forming from a molecular cloud was first proposed by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace in the 1700s. However, it wasn't until the 1920s and 1950s, with advancements in telescopes, that scientists could start confirming these theories. Further breakthroughs came in the 1970s and 1980s, with the invention of radio and infrared telescopes, allowing astronomers to peer inside dense clouds of dust and gases. By observing new stars forming within these clouds, it became clear that stars indeed originate from molecular clouds, with leftover particles eventually forming planets. But what triggered the formation of planets? In March 2003, an experiment on the International Space Station provided the answer. Astronaut Don Pettit conducted various experiments to see how substances behave in space, and during one of these experiments, he observed how salt particles inside a plastic bag began sticking together. This showed that particles in space attract one another, similar to how particles in the molecular cloud started to clump together billions of years ago, eventually forming planets.